Chapter 17, Atmospheric Science and Air Pollution. The central case for Chapter 17 is the killer smog of London. You need to know that in 1952, there was what's called an inversion layer, and we'll talk more about what that means a little bit later. But it killed a lot of people from air pollution. On the next page, 498, you need to know that nitrogen gas makes up most of the atmosphere. At 78%, you actually have to know this number. You need to know 21% for oxygen and 1% for the other gases. So the other gases are listed here, but the numbers you need to know is 78, 21, and 1 for nitrogen, oxygen, and other. Well, we're not really breathing nitrogen gas. What we breathe is oxygen gas because nitrogen gas rises into the upper atmosphere because it is less dense. So what we breathe is mostly oxygen in the troposphere, which is where we breathe, because oxygen is more dense. So the troposphere, and let's actually go right over here and look at the troposphere, which is the layer that we breathe down here at the bottom. And then you have the stratosphere, the mesosphere, thermosphere, and actually one more called the exosphere. Let's go back to the troposphere. Troposphere, where we breathe, has the most air particles. Because of density, they tend to sink towards the Earth, gravity and density. It has the most mass because it has the most air particles, highest density. Weather patterns occur here in the troposphere, and global warming occurs here. So kind of almost everything occurs in the troposphere, except the ozone layer. The stratosphere, the next layer up, contains the ozone layer that protects us from UV rays. And we'll talk about some of the problems with the ozone layer in a little bit. So what you need to know for your test is all 5 layers in order, and you need to know also the exosphere, which is not in your book, but it's on the AP test. It's the highest layer here. It's kind of the boundary between our atmosphere and outer space. It has the lowest atmospheric pressure. Page 500. Know these terms here: atmospheric pressure, relative humidity, convection circulation, what the definition of weather is versus climate. On this page, you need to know that the equator gets more direct heat. If you look here, the equator is getting direct sunlight at a 90-degree angle, and it's less distance to travel. For us, it's hitting our Earth maybe at a 45-degree angle, and so it's less intense. And so that's the reason why the equators are the hottest part of the Earth and why it gets colder, colder, colder as you go to each pole. So the equator gets sun at a 90-degree angle and a shorter distance, which equals hot weather. The poles get sun at a smaller angle and it has to travel further, which equals colder weather. A microclimate is a local atmospheric zone where climate differs from the surrounding area. A microclimate can be very small, like the bricks on your house that feel hot, or a little garden plot, to a few square miles, like San Francisco is always colder than the surrounding areas. It's a little microclimate. Okay, on page 502, you have some diagrams here about convection cells and about what causes the seasons of the Earth. So, seasons are caused by the tilt of the Earth on its axis at 21.5 degrees and the rotation of the Earth around the Sun. That's really the definition. If you don't quite understand how that works, that's okay. You just need to know this here, what seasons are caused by: the tilt of the Earth on its axis and the rotation of the Earth around the Sun, and that would be a test answer. You need to also know that high pressure system equals fair weather and a low pressure system equals rain, precipitation. Why or how? You don't need to know. There's a lot of whys and hows that we could actually go into. If this was earth science, we'd tell you why this was. But for the AP test, you just need to know that it is. We don't have to know the why. There are good reasons why, but you don't need to memorize that for the AP test. So normally what happens on page 503 in our atmosphere, this shows a warm front coming through. Normally when we have air pollution, it dissipates up into the atmosphere. Occasionally we have a thermal inversion. And I'll show you that here. What happens is that you have this layer of hot air that traps pollution. That's called a thermal inversion. It can happen a couple of ways. So you have a warm band of air between two cold masses of air. It traps air pollution, and it happens in a couple places. It happens in the coast where an ocean breeze can blow cool air under warm air. So in the summertime, you have warm, 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 and then all of a sudden an ocean breeze puts this band of cold air right here, and the pollution can't get past that hot band. It also happens in cities next to mountains where the mountains cast a shadow and cool the city in the late afternoon. The lower air mass cools while the sun is still warming the upper air mass. This happens a lot in Southern California. Our valleys are surrounded by mountains, and in the late afternoon, that casts a big shadow. And so in the summertime, you can get a lot of air pollution in the afternoon due to this inversion phenomenon. Page 504. On this page, we talk about why certain areas of the planet are rainy and why some are wet, or some are dry. What happens over the equator is that the water and water on land, water in the ocean evaporates, and then it immediately condenses, and then it rains back here on the equator. So the initial equator is pretty wet because of rain. But then that air moves north and south 30 degrees in latitude, so 30 degrees north or south, and then falls as cool, dry air. And so if you live around the 30s north and the 30s south around the world, you're going to be dry or kind of deserty, and that's where we are in Southern California. We're kind of dry and deserty because we live at 34 degrees north latitude. And so we have these cells, and you need to know these cells, where warm air rises, cool air falls, warm air rises, cool air falls. And so you have rain, rain, dry, rain, dry, rain, dry. So rain at the equator, dry at 30 degrees, rain at 60 degrees like where Seattle is, and dry at the poles. So the poles are very, very dry. They're like deserts except they're cold. And the same going down here, rain, dry, rain, dry. And we have these cells of rising and falling air patterns. So the two cells here are called polar cells. And then we have the two surrounding the equator that are called Hadley cells. And in between, we have two Ferrel cells. Yes, you need to know the names of the different cells for your test. So again, the best thing to know here is that deserts and arid or dry climates occur at 30 degrees north and south latitude and also near the poles. The equator at 0 and 60 north and south latitude are usually rainy for this reason. Now, because warm air rises and falls in these cells, these circles, but the Earth is actually spinning. And because the Earth is spinning, it diverts the wind away. Diverts the air, and that's what causes winds. So warm air rises and cool air falls, and the spin of the Earth causes winds. So I have that here on page 505. The Coriolis Effect causes this. So the Coriolis Effect works in the ocean with water. It also works on land with the air. So the rise of warm air and the fall of cool air every 30 degrees latitude, which we call a convection cell. So again, this thing we call a convection cell or convection circulation. The spin of the Earth on its axis deflects this air, and this is what causes winds. So convection cells plus the spin of the Earth, that's what creates winds. page 506. Well, now that we've talked about how the atmosphere works, let's talk about air pollution. Some air pollution is natural. Dust storms, volcanoes erupting, fires that are natural caused by lightning. Point source pollution, we can point to the source, just like with water pollution. If you can point to it and say it's that factory, it's that place, whatever, it's called point source. Power plant smokestacks, etc. If it's a bunch of little things together, a bunch of little cars, a bunch of fireplaces, we call it non-point source pollution. Page 507, the Clean Air Act. The Clean Air Act provisions. What does the Clean Air Act say? Well, the Clean Air Act gave standards for air quality, and it gave emission limits for industry and transportation. So it sets standards. Air quality can't be worse than this number. And cars cannot pollute past this number of air pollutants, and industry cannot pollute past this number of air pollution. So that's called an emission limit. An emission is something that you release like in a smokestack or a car tailpipe or a chimney. The Clean Air Act provided funds for pollution research. It also let citizens sue violating parties, and it also allowed cap-and-trade pollution permits, which we talked about earlier. You need to know that California emissions are the lowest, which means the best in the nation, because we have the worst air. So our cars cannot emit nearly as much pollution as a car in Kansas. We have smog checks. We have lots of special gasoline blends to reduce our air pollution because our air pollution is pretty darn bad. You're going to have a chart of the different kinds of air pollutants. Make sure you study that chart for your next test. Page 508 talks about particulate matter. It's a one type of air pollution. You need to know the difference between fine and ultrafine. So this is actually 2.5 nanometers. So any kind of particulate matter, like dust or soot, things like that. Ultrafine is 0.1 nanometers. That's terrible because fine, you can kind of cough out. Your lungs go and you cough out dust or things like that. But when it's smaller than that, our lungs don't even recognize them, and it gets lodged into the alveoli in our lungs, and that's a bad thing. Smokestacks can have two different kinds of things on them to remove the air pollution out of the smokestack. It can have something called a wet scrubber, which removes sulfur dioxide, or it can have an electrostatic precipitator, which removes particulates. And these are two different items that you need to know which one does what. And so we have here the different kinds of air pollutants that the Clean Air Act and the EPA monitors: carbon monoxide, NOx, VOx, sulfur dioxide, particulate matter, and lead. And again, that chart goes through all of the different ones, so make sure you study the chart as well. You can look at lead. Lead's gone down almost to zero because we've banned leaded gasoline in the United States, and that has led it to be almost zero. If you look here at the number of counties failing to attain clean air standards, these are the 6 different kinds of air pollutants, and look, LA County fails in all 6. This is one of the reasons why California has the strictest laws, because we have the worst air pollution for a couple of reasons. First, we have a ton of cars and a ton of people. Secondly, we have a bunch of mountains, and because of inversion layers, the mountains tend to trap pollution. So we have a lot of people with a lot of cars, very little public transportation, living in a place that has valleys and mountains, and all of that adds up to very bad air pollution.